Okay, second part of Pascal's triangle here. So it's kind of applying what we know about Pascal's triangle to different situations. So a situation like this may exist where you have a path, like we're playing checkers here. So the question here is, how many paths could I take to get to the end line, right? And with checkers, you have to go on diagonal. So it kind of looks just like Pascal's triangle. In the sense from here, I could go this way or this way, but there's one path to this spot, one path to this spot. Now, if I go this way, there's one path to get here. If I go to the middle here, there's two paths because I could go here and here, or I could go here and here. So that number is going to be 2. And this number is going to be 1 because the only way I can get to that spot is by going here, then here. And it looks just like Pascal's triangle here. So one path there. Here, I could go this way. That's 1. I can go this way, or I could go this way to get there. So it's 3. 1 plus 2 is 3. 3, 1. Now here, I don't have another spot over here, so it's going to be 4 right here. Because there's 3 ways to get that spot, 1 way to get that spot, so inclusively it's 4 ways here. 6, 4, 1. And I just keep building. Now here, the only way I can get here is this way. So that's going to be 4. Here's going to be 10. Here's going to be 10. Here is 5, and then we're done. Next one, there's 14 ways here. 20 ways, 15, and 5. And lastly, the only way I can get here is 14. This is 34. This would be 35, and this would be 20. Now, how many total ways to get to the end line? It's going to be 14 plus 34 plus 35 plus 20. Now, what's that? 69, 89, 90, 103 is my rough math. So there's 103 different ways I can move from this spot here to get to any one of the end line spots there. Okay? Now, if I said how many spots to this spot, it'd just be 35 or so and so forth. Now, for this one, we have this situation where there's blocks. So we're starting at this spot here, so it's going to be 1 and 1. It's going to be 1, 2, 1. Now I can't go this way, so it's going to be 3, 3. And my only spots here are 3 here, 3 here. Then we're going to have 3 here, 3 here, 3 here. And now we have, going down here, we have 3. This equals 6. This equals 6. This equals 3. We have 3, 9, 12, and 9. So it'll be 9 plus 9 plus 12 plus 3, which is going to be 33 altogether. Okay? So if you have paths or kind of diagonals, that's where you can use Pascal's triangle to find out how many ways to get to the end. Okay? Now here, I could ask the question, how many different pathways, how many different ways can let's see, how many different ways could I spell this word going down my path here? Okay. Well, it's kind of the same thing here. This would be 1. Start here, that's 1 way. It's 1 way to get here. That's going to be 1, 1, 1, 2, 1. That's going to be 1, because I can only go this way to spell it. 3, 3, 1. And continue on creating my Pascal's triangle. Now it's going to squeeze in again, just like they did before. 1, 6, 15, 20, 15, 6, and 1. Then when we get here, it's going to squeeze in. So we're going to have 7 here, 21, 35, 35, 21, and 7. Here's going to be made this way, which is going to be 28. That's going to be 56, 70, 56, 28. And adding these two together, what's that, 70, 84, I believe. 126, 126. And that's going to be 210, 210, 252. 2. And add 210 plus 252 plus 210. So we're just always adding numbers above as such. That's 672 altogether, I believe. Now we could do something like this. Let's make one of ourselves. And here's one. Basketball. So it still starts with a 1. It just then it'd be 1 1, 1 2 1, since we're still adding like here. And this is going to be 3 and 3. This will be 6. This is going to be 6. This is going to be 6 because this adds a here. Now this one hypothetically is here and here, but there's nothing over here, so that's a 0 over there. It's going to be 12 and 6 and 6. 6 still over here, 18, 18 and 6. 24, 24, 36. And that's going to be 4 is 40, 60, and 60. So the answer is going to be 120 all the way through. Okay. So that's one way we can do that. So now the fun part. Finding on a grid how many ways it would take us to go from one spot to the next spot. Okay? So there's 2 ways to do it. The simple way and the incredibly difficult way. Let's make one over here. I'm going to try to make a simple grid. It's a little bit smaller. So let's say I started here. This is my start point. And this is my end point. Actually, yes, I'll go from there. So that's my start point. This is my point. How many different ways going north or east it would take for me to get there? Well, from here, I could go here or here. There's one spot there for each one, right? Now, if I go one layer further, there's 2 ways to get here. One way to get here, one way to get there. Now, to get this intersection to be 3. So I could go, I'm connecting here and here together to get that spot. Okay. For here, it would be 3 as well. So I'm going from here and from here. So pretty much Pascal's triangle, we're going this way. Now, there's one way to get there. We'd be 1 here. We'd be 4 here. We'd be 6 here. 1 to get there. There'd be 5 ways to get there. 10 ways to get there. There's 4 ways to get there. There's 10 ways to get here. So, like, for example, if I get here, I'm connecting this and this together. Okay, and I'm continually connecting. Now, for this spot here, it would be 10 plus 10, so that'd be 20. Okay, for this spot here, that'd be 15. And thankfully, that'd be 35 by connecting this one and this one. Okay, that's a little laborious. So there's a different way to get this. Okay, the different way to get this is as follows. What color should I use? Let's use this one. Now, if you think about it, does it matter when you have to go north or east? But it doesn't matter when you go north or east. You have a certain number of north moves to make, a certain number of east moves to make. So if we consider north, our north moves, we have to go north 1, 2, 3 times. So we have to make 3 north moves. Now if we consider our east moves, we have to go 1, 2, 3, 4 times east. So in total, we have 7 moves to make. Okay? And it doesn't matter when you make it, so order doesn't matter. So it's actually a combination question. And we can base our answer off either north moves or east view moves. So 7C3 should equal the same number. 7C3 equals 35. And I can actually go 7C4, and that also equals 35. Now we know that because 7C3 equals 7C4, because what's 7 minus 3 is 4. Okay, and those two numbers are symmetrical. Now it's a lot easier, instead of adding up all those moves and working through it, to recognize the total moves you need. So this is total. That's our total moves. And then doing either our east or our north moves to get the answer. Because when you get a much larger grid, it's going to be a lot harder to write those all out. And you may lose track. If you lose track of one, you're lost. So if we go over here, if we're going from S to M, only going north or east, we have 1, 2, 3, 4, 5 north moves to make. 5 north moves to make. And we have 1, 2, 3 east views to make. The total moves is 8. So we can calculate this by 8C3 or 8C5. Both are equal. And that would equal 56. So there's 56 total moves. Now, do we even try this the old-fashioned way? Let's try it. So we can go one way here, one way there. We can get that intersection 2 ways. We can get this way 1, this way 3, this place 1, this place 3. This is going to be 6. We can get this way 1, this way 4. This one's going to be 10 with these two numbers added together. This is going to be 1, this is going to be 4, this is going to be 10. We can get this way 20 ways. Now we can get up here 1 way, that's going to be another 5. Up here is going to be 6. This is going to be 15. This is going to be 21 because you bring these two numbers together. This is going to be 35, bringing these two numbers together. And this here equals 56. So we got the same number here and here. This is a lot cleaner to do. Right? So let's do this one here again. Let's change this dot up. Let's put it over here. So how many moves from there to there? Well, we have 1, 2 north moves. We have 1, 2, 3, 4, 5 east moves. So our total is 7. So this can be 7C2 or 7C5. And those are 21 different ways. Now you can see how quickly that is compared to writing it all out. Now let's say we want to go from A to B and then the C. Okay? So when we do this, we're just going to do it twice. We're going to have 2 calculations, and we're going to multiply them by each other. So the first one, from A to B, we have 1, 2, 3, 4 north moves. And we have 1, 2, 3 east moves. So that's going to be 7C4. That's what I'm going to put in there, 7C4. Now I could do 7C3 as well. That's the exact same thing. Now to go from B to C, and we're going south this time. 1, 2 south moves. Oh. My dog is not feeling well right now. We have 2 south moves, and we have 2 east moves. So that's going to be 4C2 altogether. So that's going to be my 4C2 here. And then I'm going to put these together. So 7C4 times 4C2 equals 210. So there's 210 possible pathways I can take from A to B to C. Okay, let's do one last one. My big bird go. Okay, so this one, I want to go from S to J to M. So if you want to try it, pause it as I go through this. Okay, you can pause it now, then come back and see the answer. So S to J, we're going north first. We're going to go 3 north. And we're going east 8. So that totals 11. So it's going to be 11C3, or I could go 11C8, same difference, right? And then my J to M, I have north, I'm going 1, 2, 3, 4, 5, 6, 7 north. And east, I'm going 2. So my total is 9, so I'm going to times it by 9C2. And there's my answer. So 11C3 times 9C2. I have a total of 5,940 different ways I could go from S to J and J to M. Okay. And I think that's it for today. So there's 3 things we're looking at. One is working through Pascal's, try and go through a grid, such as this. Another is working through like words. If I had to make my way down, how many pathways are there? Now, it could also be a game of Plinko, where I drop a ball, or this one. If you ever watched Price is Right, they have Plinko. As in, I drop a ball through a chute right here. So I could go here and here, be 1, 1. That'd be 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. And let's say there's bins here for the ball to fall in. Okay? So that's how that kind of could work. I have one more. Oh, I got this one here. I could do over 2. Okay, and then we have pathways. Pathways here, where we use combinations to figure it out, using north and east or south and west or whatever directions you want. Where we have the total. So total moves here was 7 moves, and we can use east or north to figure it out, because we know that 7C4 equals 7C3. The last one is kind of one where it's kind of an abnormal shape. And this is where we just apply Pascal's general thinking knowledge. As in, if we start here, and we're going to finish over here, there's only one way to get to this dot. There's one way to get that dot, and one way to get this dot. And then we keep, this is the rule, we're always going forward. Think about it like if you're progressing through a park. Now to get this dot, there's only one way. To get here, we could come from this one or that one, so that's 2. Then we have this one here, which is going to be 1. This one here is going to be 2, because we can only come this way. We're at 1 again here. This one's going to be 3, because we can come from this direction or this direction to get 3. Then lastly, our final dot is going to be 1 plus 3 plus 1 coming in here. So 1 plus 3 plus 1. So our final pass, how many different paths can we take? There's 5 different ways we can get to the end. Okay? So hopefully that helps out, and you can do the number 2 practice right now.